Fine. I think the next slide will be good. Okay, this is my introduction. You know me already. Omojola Akintayo Daniel, Department of Radiology, Medical Physics Unit, Federal Medical Center, Asaba. So our laboratory exercise will be looking at determination of TLD calibration factor for conventional imaging. Actually, when we talk about calibration, TLD there means thermoluminescence dosimeter. So basically, we want to use lithium fluoride doped with magnesium and titanium for this study. So the next slide. Okay, fantastic. We have, let me go back a bit. Sorry for that. I think the images are a bit heavy. Let me take it back. Fine, fantastic. I would like to show us from here is a set of TLD chips on this tray. Now, this tray is actually made of a very hard metal and can absorb as much as 400 degrees, 600 degrees of heat. So right here is our aniline oven. And here is the calibration. I can take this 100 to about 400 degrees C. So it is assumed that for this process, our chips are ready. Our chips were annealed here. And now, because before you start taking any measurement, your chips have to be annealed. And in my last class, I told us that in order for you to anneal your chip, you want to remove residual energy from your chips to make sure that your chips are actually back to background, close to background. Tentatively, you can't achieve background. It's not possible, but we want to be something close to that value. So we place them here, and then we heat them up for about 400 degrees for 1 hour. Then later on, we heat again for another 2 hours at 100 degrees C. The 100 degrees C is for us to remove lower peaks from our background. Now, close to this place is the normal badge. When you go to a radiology department, you see people wear their badge. This is actually what it looks like. Now, these points are where these round chips fit in. So this 2 is for our deep dose. This 2 is for our shallow dose. Now, I can put this on this holder, and then you can see the last hole. I mean here, the last port here, you can clearly see it here. Another one is here, and so on. So the following assumption was made. The TLDs were annealed. They were taken to a secondary standard dosimetry laboratory, SSDL. Precisely, we took them to Ibadan for irradiation, which is a secondary lab. For irradiation using a cesium source. That is cesium-137. I hope you can hear me clearly. Can you hear me clearly?
Yes, we can hear you. We can hear you. Right on.
Fantastic, fantastic, fantastic. So they were irradiated to 5, 6, 7, 8, 9, 10 milligray. So we practically took them for irradiation. I want to just show you something. This is the setup you are going to see in a secondary lab. This is your cesium source, and these are your TLD chips here. Now, after we've taken them there, remember we have to go with a few chips that actually will not be exposed to radiation. We call them transport dose. They are actually background dose. So we are not going to expose them to the cesium source, but they are among the chips we took down to the secondary lab. Now, after these chips have been irradiated to known doses, 5, 6, 7, 8, 9, 10 milligray, we are going to bring them back, and definitely we are going to read each one of them We are going to read each one of them. And this is the device we actually use in reading them. You can see the chips here. Under this is a thermal, a heating medium, and then your ions, your electrons will be counted. And this is just practically the setup. So reading was done for the exposed and non-exposed TL chips. And we had plenty of results. Now, this is assumed that we have done this. And practically for 5 milligray, an average of 3 chips were used. For 6 milligray, an average of 3, 7, 3, 8 milligray, 3 chips, and so on. So we now have to look for their average, and then we have something like this. So our TLI is our actual count. Then our T0 is our background count. So it means we've done some few deductions here. We've done some subtraction here, and this is what we actually got. Now, this is our known dose in which our chips were exposed to. They were exposed to 5, 6, 7, 8, 9, and 10 milligray. So what is our question? Our question is very simple. We are going to plot a graph of dose against count. So we are going to plot a graph of this dose against count using our Excel sheet. Now, 2, we are going to determine the element calibration factor from the plot. Now, you should know that the slope from the line graph will be calculated using y is equal to mx plus c. I know we all know that. School physics, part 1, part 2, all through. Where our m is equal to our slope, and practically, it is our calibration factor for the TLD chips between 5 to 10 milligray for those set of chips now. Now, we now use the line graph. We use the line graph from the plot to determine the average deviation of the TL chips from the known dose. So we want to know how much those chips deviated from the known dose. So our hint here is using y is equal to mxc. Percentage deviation is equal to d fit, that is from our graph, minus d actual, which is from the cesium source, divided by d actual. So we use that to get our value. Practically, we have to kickstart and get ourselves ready. So I think I did share the link. I feel we need to get the link immediately. Dr. Yobosa, if you are there, you can also share the link. So we have plenty of links to share. So I want to assume that we all understand the process. We are using the table there to draw our graph. Practically straightforward. Dr. Yobos, are you sharing the link? We are both going to share the link so that it will be very fast. I think I've shared the link, but I still need to do that again briefly so that everybody can get that clear. I think I should stop sharing the screen. And yes, I'm there. Sorry, there is a lot of heat here. Okay, fantastic. I think that is the link. I'm sharing again. So we get going. Sure. I'm sure. Are we gotten the link? Okay. Thank you very much. Our time starts now. So we are going to plot. So on the vertical axis is going to be your dose, and then on the horizontal axis is going to be your TL signal, which is in microcoulombs, and our dose is in milligray. So can we try that? I'm doing that here also. So So for some of us that may not be able to use that, you can practically copy it straight to your Excel sheet. Now, from your Excel sheet, you can just practically draw that. I mean, offline, you can quickly do that so that we can get, yes, this is actually what we want to do. This is actually what we need. So I want to know if there are responses, people are actually getting how to use the Excel sheet, because I know it's going to be a problem a bit. Dr. Yobosa, are you also plotting? You should be plotting. Everybody should be plotting.
Really? What should
this time around, if your internet facility is not too good, you are going to find it a bit difficult. But I think what you should do is copy from even the PowerPoint, paste it on your offline Excel sheet, do the plotting. What I need from your Excel sheet is the line graph. Y is equal to mx plus c, your line graph. That is practically what I need in your Excel sheet. So from your Excel sheet, most likely, yes, I think I need to share this. I don't know, I'm not getting a response from people. Is response coming? I have to go and look at responses, whether people are actually, okay. I need more people, more. I want to believe this is a bit easy. Anybody with a graph? Anybody with a graph? Okay, somebody wrote calibration is 5. Is it okay? Somebody wrote calibration is 5. And we are going to see our answer. I need more answers for us to get our calibration. Then that person that got 5, calibration factor is 5. He needs to move forward and determine using the line graph to plot to determine the average deviation of the TL cheats. Now, you are going to have your y is equal to mx plus c. Your y will be equal to your line graph. You know, your line graph is having an x value. Now, your x value is this dose here. This is your x value. I mean from here. somebody has gotten something reasonable, but is missing something out of it. So I need more answers, more answers, more answers, more answers.
Mr. Akin, would you like to share your screen?
For the what?
Because it appears that you are you keep referring to something on your screen, and I'm the one sharing my screen. So would you like to share your screen so that we can see what you are pointing at?
Okay.
Yes, so you haven't been sharing your screen. I've been the one sharing my screen.
Okay, you can actually go off. You can, okay.
No, share, don't worry, share, you override mine. So to be sure that what you are doing is working. So just share yours, it will override my screen.
Okay, fantastic.
Yes, because you seem to be pointing to things that we can't see. So please share your screen so that we can see exactly what you want us to see. Can you even see my own screen?
Sure.
Okay. So the data and the questions are displayed at the same time, so that those that cannot access the Excel sheets can just copy it off to another program and plot the graph.
Are you seeing my screen? Not yet.
Not yet. Okay, we can see your screen now.
Okay.
Yeah.
I saw there's somebody's image showing, and I don't know how you can solve this question on the road. Quite difficult. I don't know how it's going to solve the question on the road. So, but I need more answers. Are answers coming? Somebody sent, person said 5. So I need more. Okay. Let me go through, let me check and see if we can get more answers, Wow, Basil Okache, yes. M is equal to 5 times 10 raised to power minus 6. Okay. Chuku, no, Ugu, Ezike, no, Ugu.
Ugu Ezike, Chekube.
Ezike, his calibration factor is 5. Abba Musa, 4 times 10 raised to power minus 6. Now, your value must be times 10 raised to power minus something. I'm giving you an hint. So I'm seeing some wonderful answers here. Only few persons.
What you got 5?
Allah El Sadiq, 208.835.
Oh boy.
You are quite far from the answer. You are quite far from the answer. So we have, I'm still getting more answers. I got a slope of, from Godwin Agbajo, I got a slope of 4.96 times 10 raised to the minus 6. Fantastic. Well. It is until when we see the answer, you are going to mark yourself. Okay, from Udunola, 4.9 times 10 raised to the minus 7. Please, you have to recheck your calculation well. Look at your zeros well. Sani Mawan, 203 times 10 raised to the minus 3. Absolutely, you have to do it again. You have to do it again. Your answer should be, should I tell them the answer? Sure, that is why we are here. Is it time? I need them to get this. They must all get it correct. I'm going to share the answer, but some people are doing something reasonable, so they don't go back and change the answer again. That might be another problem. So you should be getting something close to 5 times 10 raised to the power minus 6. So Chekube, you have to check your times 10 raised to the power minus 6 well.
You've even already told us the answer already.
But they need to work towards it. They need to work towards it. Several. I'm seeing so much answers
Okay,
here.
so I can just type the answer now since you told me already. Let me type.
So, Dr. Yobosa, you mean you didn't do anything? So, can somebody now tell us here? We need to know what is I think we need to know what is our now for those of us that have gotten the answer. I don't know, maybe I should just share because of time, or how many minutes do I have? 30 minutes?
No, 15 minutes more, please.
Fantastic.
Yeah.
Then it means you are going to add more to it. Okay, fantastic. I'm going to use the 15 minutes judiciously. Okay. So for the other side of the question, I also need us to use this particular equation, because from what you have gotten an equation, y is equal to mx plus c. You've gotten an equation, y is equal to mx plus c. So you will go back to that your calibration factor. So you are going to say y is equal to the first TL count. Your x is going to be, your calibration factor multiplied by your first TL count plus your intercept. That gives you something close to your first dose. I don't know what I'm saying is, you understand me? Okay, let me look at the chat box quickly, and let's. Wow. Okay, somebody got Emmanuel Ojo. Okay, 5.9. 1, 2, 3, 4, 5, 6. 5.9 times 10 raised to the power minus 6. Maybe a few approximation that cost that. El Sodiq, 2.8 times 10 raised to the power minus 4. Possibly you are not, you're a bit close to the answer, but not. Basil Okocha, I don't understand what you are asking. Possibly I need to get you well.
He wants you to repeat the last statement you just made, I think.
Is it okay? The last statement.
I think so.
The last question we want to deal with is practically, we want to see how much the dose from the cesium source. You know, the cesium source was our TLD were exposed to 5, 6, 7, 8, 9, 10. Now we now got a graph. We got a line graph. Now from our line graph, we can use back our line graph to get back our known dose is. So you just use that equation back, plug in all the values. You remember that as physicists? Yes. When you get an answer, plug in your answer back into y is equals to mx plus c. Remember that your answer is a line graph. It's actually 5 times 10 raised to power minus 6x plus 0.0, something like that. Now, from that equation, plug in your x value. Your x value is actually your first TL count. Plug in that value into the equation back. It is going to give you something close to 5 milligray. The next one is going to give you something close to 6 milligray. Then use this formula to determine the percentage deviation. We want to see how much our TLD chips are deviating from the known dose. So we want to see how far it is deviating from the known dose. So basically, I need to get my small pen and do something. I think we still have some little time. And then more answers. I'll be to see your answers. Okay, Godwin Agujo, I got 0.5285. Possibly no. Yes, Maman Kanini, your slope is actually 5 times 10 raised per minus 6. Can you please share your intercept, your C? Can you please share your C value? You know, it's a line graph. Y is equal to mx plus c. Can you share your C value also? Maman, you are correct. That value is correct. That is the slope. 5 times 10 raised per minus 6. Correct. Can you please share your C value? Fantastic. That is your C value. Your C value is Basil Okocha, you are correct. Your C value is 0.0376. Christopher Oyeola, you are correct. 5 times 10 raised to power minus 6. Share your C value also. Your C value is also very important. Now go back and plug in your first value here. Go back and plug in this value into that very equation. Go back and plug in this value into the equation, and then.
Mr. Aki, what about the graph? Can we see the graph?
Okay, can you please, you also have the link. Can you share?
No, I'm wondering if people actually plotted, how are we sure that people actually plotted this thing?
Okay.
So we can actually see if people have their graphs, they can share with us so that we can see how the graph looks like. So
okay, we can tell somebody to share.
Yes, anybody that can share the graph. Let's see how they
think
actually.
let me look at I think somebody got he shared the C value. Maman, can you share your graph? Is Maman there, or we are giving you the floor to share your graph? We want everybody to see that.
Okay, somebody is actually sharing her video. I don't know if it's a he or a she now.
Okay.
Somebody, if you look at the video, somebody is sharing the graph through the video. Can you check the video of the participants? I don't know who this person is. Agnes is sharing. Is it Agnes? Okay, no, Basil is sharing his graph. Can you see the video? Can you see it, Mr.? Can you see the videos, Mr. Omojola?
I'm not seeing anything here.
Yeah, somebody's actually sharing the graph.
Okay, can we if we are getting his
You need
name,
to,
can
Basil,
it
you need to
Basil?
put your videos in gallery or something, gallery view, so that you can see the videos of the participants. And people can also share it through the chat. If you have the file or something, you can just you can paste the link and he can also check it that way. But Basil, currently from my own end, I can see Basil Okache
Yes,
sharing his
okay.
video. Can you see it from your own end?
I'm trying to look for it.
Are
Where
you
it
using a
is.
phone or a computer?
I'm using a system. Yes, I'm using a computer.
Okay, so you need to put your videos in gallery so that you can see
Okay.
all the participants. Yes. Or yeah. So you
Okay,
can
I'm
just
seeing
scroll
yes,
through
I'm
them.
seeing Basil.
Okay, yes. Okay, excellent then.
Yes, I'm seeing Basil. Fantastic. Yes, that is a graph from his screen. Yes, you have something like that. Does it want to share it so that everybody? Okay, should I share what our results look like? Okay, somebody
No,
has
not
pasted
yet.
something.
Not yet. Yeah,
Not
somebody has
yet.
posted. Yes, let's see. Let's see if people actually plotted. I'm scrolling
Tosin
through. I can't see any other
Ijal
person.
Ijal
Ijala,
yes, Ijale, yes.
People are sending their files through the chat, so you can also check to see if they did the right thing.
Yes, I'm trying. I want to open Basil,
Okay.
wonderful. You did something great there. It's you're on point. You're on point. So
Okay, can I share my screen?
okay, you can, please. You can.
Yes, so I can open people's I can
Please,
open
you
what they are
can.
sharing. Yes,
You
now.
can do that. You can do that. You can do that.
So this is from Tosin. Can you see? This is Tosin's graph. Can you see my screen? You can't see my screen. Oh, really? Why? I'm sharing my screen. Uh-oh. Can you see my screen? Uh-oh. I don't know what happened. But it says here that I'm sharing.
Okay. I think I will need to just take off my PowerPoint so the congestion will reduce from my end here a bit. Seems my system is just
Can you see my
doing a whole
screen?
lot of. Basil Okocha, well done. We've seen what you have done. I want to get more of the charts and then respond to them, and then we quickly see what our result looks like.
Okay, people can see my screen. So who cannot see my screen?
I'm seeing you.
Okay, can you
Your
stop
screen.
sharing? Mr. Omojola, can you stop sharing your screen, please?
That is exactly what I think I should.
Okay, so the problem is from you then. So stop sharing because I can see my own screen and somebody can see my own screen. Can you see my screen now? Yeah. Technical, can you see my screen? Okay, so this is from Tosin. Okay, so I'm just going to share the next person. Can you see Mr. Omojola? Are you okay with the graph? Where is he? Is it still in the chat? Is Mr. Omojola still there? Oh, okay. So wait for him to come back. So thank you, Tosin Jale, for you. But I'm just, if I can make my own comments, as physics students, when you're plotting a graph, you need to label your axes so that we know exactly what you plotted. So we're just seeing numbers now. We don't know what is on the X and what is on the Y axis. So that's one thing to take note of. Physics, you need to label your axis. Okay, so let me share the next one. This is from, okay, so how do I share this now? Okay, so this is from another person, Jesuto Fumi, our technical support. You didn't label your graph. Okay. No, you need to label your graph. You can lose marks for plotting a graph like this. Okay, let's find Mr. Akin so that we can round off. Let me see if he's back in the chat. Oh, Mr. Akin is no longer here. Does anybody want to share his or her graph with us? Okay, Mr. Akin is trying to join back. He has asked me to share the answers, so I'll just try and download it from my. Can everybody see my screen? So these are the answers to the lab as asked to be shared by Mr. Akin. So he will come up soon and explain. Is it there already? Okay, so let me unmute him.
Mr. Akin, please, could you continue? Can you just round off?
Yes, I'm on. I'm on.
Yeah, we know.
I think Dr. Yobosa is sharing the screen. So once the screen is up, we just quickly explain a few things from the screen. And I got several mail through the Harmattan school, people uploading their, so I'm going to check their graphs and I'm just going to get across to them. So you can send as many graphs to me. Everybody that partook, you can send as many of your graphs. I'm going to sit down, look at them, paste if there's need for a correction, paste correction, then send back to you. Possibly, if you are sending that, you can send your your email or possibly. What do you think, Dr. Yobosa? It's taking time. It's quite taking time to come up.
Yeah, I don't know. I'm sharing. I can see it here. I don't know why you can't see it on the other end. Can you share your own screen?
Possibly. Let me see if.
Okay, so just try, or you can just while we are waiting for it to come, you can just summarize the answers.
Okay. I think the table will be very good so that okay. I think I should share. I should just quickly wrap it up here. Is your screen coming up? No. Well, can you unmute? Can you allow me to share my screen? Okay.
Yes, you can share.
Okay, I think, okay. Thank you. Let me do that immediately.
Please, Mr. Aki,
Yeah,
could you help us wrap it up in 2 minutes? I think we don't want to run them behind them. Michelle, it is already 10:45 a.m. It was the initial timing. We had a plan
yes.
for the closing remarks and to comments. Please, if you could help us do that quickly so that we have representative from NAMP and IPEM.
Okay, I think basically our slope is 5 times 10 raised to the power minus 6. I want to share, but it's a bit difficult to share. Dr. Yobosa, from your end, are you getting anything? I'm trying to share. It's a bit difficult here. I think it's a bit difficult here. Okay, let me go through my Google Drive if possible.
Can you share your screen now?
Yes, let me go through my Google Drive and just simply share that quickly and see what it's a bit it's asking for so much password. But I think we should share the link so that they can see it. They can see it clearly from the link. Let us share that quickly. Let me share the link quickly for the answers. Sorry for the break. Let me share the answers immediately so that we can have an understanding of it quickly. I think I should do that. Okay. Okay. It's a bit difficult. Dr. Yobosa, can you just quickly just share the link so that everybody could
Mr. Akin, can you see the video? Can you see the screen now?
Okay.
Yes.
Fantastic.
So
yes.
Just 2 minutes, please, to round off.
Yes. And I think from the screen we can actually see we can clearly see yes, the Li minus TL naught. That is actually what is exactly from our question. Now let us move to the other side. We can see the line graph. The line graph, that is actually the line graph of our actual dose in milligray against TL signal in microcoulombs. Now you can see that the line graph are quite, it's a fit, it's a fit. And now you try to look at your R square. Your R square is almost close to 1. When your graph is actually close to 1, it tells you how those values actually fit your line graph. Now, y is equal to 5 times 10 raised to the minus 6 plus 0.0376. I hope that is clear. Now, coming down here, you can clearly see y is equal to mxc. So I practically got back what I call, let us go down a bit. Can you take it down? Move it down. Yes, move it down. Fantastic. No. Take it to the last graph. Yes, thank you. So we have our fit. Now, our fit was gotten from y is equal to mx plus c. So our fit for the first actual dose is 5.04. The second is 6.04. The third is 7.09. The fourth is 8.04. The fifth is 9.04. And then for the actual dose of 10 milligray is 10.1. Now, the next place is our error. You can clearly see the error. Then remember that the formula is percentage deviation is actually your error divided by your actual dose. And your error is your actual fit minus, your actual minus your dose. Your actual minus your dose. Do we get that? So now this is our deviation. Our deviation for 5 milligray is 0.77. Our deviation for 6 milligray is 0.72. Our deviation for 7, which is actually the maximum, is 1.25. Deviation for 8 is 0.55. 0.9 is 0.46. And then deviation for 10 milligray is 1.04. Now, the overall deviation for this study is about 0.8, which is quite less than 1%. No, for diagnostic range, this deviation is actually possible, but a bit difficult to achieve because of several uncertainties that occur with your TLD chips, that occur even in the SSDL lab, because there are actually some uncertainty during your annealing and several uncertainties. I will request us that we read up a particular document, the TRS 457, TRS series number 457 from the IAEA. It's a wonderful document for diagnostic dosimetry. It's going to do us real good. So I think if there's any question, I can take more questions and then we call it a session.